First of all, we need to run the start script which initializes the ROS core and gazebo simulation. This process loads the forest scenario and is also responsible for spawning the drones and starting their takeoff procedure. After this, we can start the Python ROS node that will be responsible for a couple of features that adds to the complexity of the simulation, such as image processing of the cameras attached to the drones. Once this is all done, we can run the JSON BDI agents. Each drone has an agent that is responsible for controlling all their actions during the simulation. The first thing the agent does is calculate the area in the forest that this drone is responsible for. After calculating a list of waypoints inside this area, the agent proceeds to start the search plan. For this first scenario, we have stipulated that each drone only has one charge of fire retardant. This means that each drone can only extinguish the fire of one tree in flames. This information is going to be used by the agent when it finds the fire to determine which plan of actions to take. In this case, the agent that finds the fire is UAV3. When it finds the fire, it pauses the search in progress. It then perceives that the size of the fire is 4, too big for it to handle by itself. For this reason, the agent starts a contract net protocol to determine which are the best agents to help in this mission. The first priority in the protocol is charges of fire retardant, followed by distance from the agent who found the fire. Since all agents were initialized with one charge of fire retardant, UAV3 will need the help of 3 agents. It also means the CNP will determine the best agents by distance, since the charges are the same. In this case, UAV3 accepted the proposals of UAV2, UAV5, and UAV6. When the fire retardant charges reach 0, the agent suspends the current plan and goes back to the center of the simulation to recharge. When it is done recharging, it will decide if it still is required. In this case, it will go back to the fire. If it is no longer needed, as in the fire was already extinguished, it will resume its initial search trajectory. In this case, it will use the progress information of the search plan to avoid redoing the search from scratch. Another scenario we can simulate is what happens when the drone fails to extinguish the fire. In this case, we initialized each drone with 4 charges of fire retardant. When the UAV finds the fire, it initially believes it is capable of handling the situation by itself. This changes, however, when during the second flight over the fire, it misses the target and fails to extinguish the fire. The agent then adapts and sees that it is no longer capable of handling the situation with its current charges of fire retardant. In this case, it starts a contract net protocol to call for the aid of another agent. Another feature we can mention is what happens when the agent perceives low battery. If a battery below 30% is detected, the agent pauses the current plan and goes back to the center to recharge. When this recharge procedure is completed, the agent resumes its previous plan using their previous progress. Finally, when an agent is done with its current search plan, it communicates this with the other agents. When all agents are done with their search, the agent sends the drone to a landing point, and once they arrive there, they land.